Somebody named Jackie has joined my Zoom. Oh, that looks like Braden. I'm like, who the heck is Jackie? I'm like trying to figure out why is someone that I've never heard of joining my Zoom? Here is the notes for today. Here you go. My completed notes from last time. Anybody? All right. Can you guys on Zoom, can you see the paper? Okay, good.
Yes.
All righty then. right, so we're going to start with converting fractions to decimals. And we kind of already talked about this before, but basically you're just going to divide the numerator by the denominator. Okay, so, and at this point we're not using calculators, so you just have to use long division to do that. All right. Converting a decimal to a fraction. All right. So basically, it's like right here, 0.3. When you see 0.3, you should know that's the same thing as 3/10. So that's just 3/10. Okay. And then like 0.15, that's the same thing as 15/100. And then you would always have to reduce. And then 0.125 is 125 thousandths, because your place values, you know, tenths, hundredths, thousandths. So if it goes out to the thousandth place, then it's 125 over 1,000. And then again, you have to reduce that. Okay. All right. So for examples today, we have basically, this is just the homework assignment. So I don't know, I probably won't do all of these. Maybe like every other one is what I'm thinking, or something like that. And of course, it's not your, you know, when you do your homework, the numbers will be changed. But so like, I mean, 9/10, so write that as a decimal, so that would be 0.9. 3/10 would be 0.3. 1/2, 0.5. That's just a, you should just know that, right? 1/2 is the same thing as 0.5. I mean, if you did it, you could divide it out. And I mean, yeah, you could use a calculator, but not really, because on your test, you can't use a calculator. So, okay, so 7/8. All right, so let's say we divide that one out. So 8 going into 7. All right, obviously 8 doesn't go into 7. So put a decimal point after the 7, and then that decimal point has to go right above that into the quotient, which is the answer. And I go ahead and put a 0 above the 7, since 8 does not go into 7. All right, then we're going to tack on a 0 here. So now it's 7.0. And then we're going to ask ourselves, well, how many times does 8 go into 70? So that would be 8. Okay. And then, so 8 times 8 is 64. 70 minus 64 is 6. And then, you know, 8 doesn't go into 6, so you know, bring down another 0. So 8 goes into 60. How many times? I guess that would be 7. 7 times 8 is 56. So 60 minus 56 is 4. And then do another 0. So 8 goes into 40 exactly 5 times, because 5 times 8 is equal to 40. All right, so your answer is 0.875. And yeah, you don't necessarily have to put the 0, but I just prefer it that way. All right. Number 5 says 2 1/4. So you know it's going to be 2 point. And then you just have to figure out the decimal for 1/4. Yeah. Yes, 0, yeah, so 1/4 is a quarter, 0.25, yep. If you didn't know, you could divide it out, 1 divided by 4, so 2.25. 12 7/10, so 7/10 is 0.7, so that's just 12.7. and then 3 1/8. So you know that's 3 points, and then you just have to figure out what is 1/8, so you can divide it out. I think it's 0.125 though. So these go pretty quickly. 6 1/3. So if you know the decimal for 1/3, that is 0.333 continuing. Okay, so type an integer or decimal rounded to the nearest thousandth as needed. Okay, so thousands, that's tenths, hundredths, thousandths, that's 3 decimal places. So it would be like 6.3333333. Okay, so the thousandth place would be here, and that's a 3, which is smaller than 5, so that 3 can stay the same. So it's just 6.333 for rounding it. And then 5/9. So I'm going to use long division and just divide that out. So 9 going into 5. So how many times does 9 go into 50? So I think 5 times 9 is 45. Okay, and 50 minus 45 is 5. And then you do another 0. And 9 goes into 50 5 times. 5 times 9 is 45. 50 minus 45 is 5. And down 0. So if they want you to go to 3 decimal places, then I'm just going to keep dividing till I get to 4 decimal places, and then I can stop and round it off. Okay, so in this case, to round up to 3 decimal places, that would be, here's the 5, it's followed by another 5, which means you round up. So this would be 0.556. Right. And even though it says use your calculator, you really shouldn't, because we're not using calculator. But it's your homework, so who's going to know other than you? So that would just be 3 point whatever, and you divide that out. All right, so I don't need to do that one. Okay, so 0.4, that's 4/10. And we can reduce that because 2 goes into 4 2 times, and 2 goes into 10 5 times. So 2/5 would be the final answer. And 0.275. Okay, so that's going to be 275 over 1,000, because that's tenths, hundredths, thousandths. So 275 over 1,000. Okay, so in this case, you could reduce by 5, but you could also reduce by 25. Think about, quarters. So if this is $2.75, how many quarters are in $2.75? 11, because each dollar is 4, and then 75 cents is 3 more. So if we divide that by 25, and that's 11. Okay, and see if we divide this by 25, that would be 40. Is that right? Because 25 will go into 100 4 times. Oh, wait. Yeah. Right? So, okay. So 11 over 40 would be the answer then? Any questions? Okay. All right, write the following decimal as a fraction or mixed number in lowest terms. Okay, so that's basically the same thing we just did. So that would be 85 over 100. Let's see, both of those are divisible by 5. I know 5 goes into 100 20 times. 5 goes into 85 13 times. So 13 over 20 would be my answer. One over 20. So for that, maybe you just divide it out. You could divide it out like 1 divided by 20. 20 going into 1. So let's see. 20 still doesn't go into 10, so put a 0 there and then put another 0. And how many times does 20 go into 100? That would be 5. And 5 times, because 5 times 20 is exactly equal to 100. So there you go. 0.05 is the answer. Write 0.02 as a fraction. So that would be 2 over 100. And then reduce that. 2 goes into 2 one time and 2 goes into 150 times. So 1 over 50 would be the answer. Let's see. I don't need to do all these. Which one should I do? Which one should I do? 14 over 16 or 3 over 22? 3 over 22? Cool. Let's do that. All right. So 22 goes into 3. Okay, so 22 goes into 30 one time. 1 times 22 is 22. 30 minus 22 is 8. And then let's do another 0 here that we can bring down. And then 22 would go into 80 3 times. So then that would be 66. So 80 minus 66 would be 14. And then let's do another 0 that we can bring down. And then 22 would go into 140. How many times? 6 maybe? 7 would be definitely too many. We do 6. I think that will work. So that'd be, let's see, 6 times 20 would be 120. 3 is 12. 120 plus 12 is 132. And then 140 minus 132 is 8. Okay. All right. And 22 goes into 80. 3 times, and 3 times 22 is 66, and 80 minus 66 is 14. So I see we have a loop here that we're doing, and that would be 6. Okay, so I think it's going to be 1, 3, 6, 3, 6, 3, 6, 3, 6, 3, 6. Is there supposed to be a 0 in there? Like this one? I don't think so. Let's see. I don't think so, because I mean, I just brought down the 0 and then yeah. So that's kind of weird. But maybe let me just check myself with a calculator real quick. So 3 divided by 22. Okay, yeah, so I'm right. But I guess so out of the choices that they've given us, then the closest option would be this, because if I round it off to 3 decimal places, it would be that. All right. Okay. Let's look at the next page. Number 28 is interesting. Find the decimal representation of 37 over 99. So if we were to use process of elimination, I'm thinking, 2 of these answers I can eliminate right away, which would be what? A and B. A and B are definitely no, because 37 over 99, that's less than 1, right? Because the numerator is smaller than the denominator. So that's less than 1. So it can't be 99 point something or 37 point something. That's definitely wrong. Okay, well, so we can actually do this without even really doing, dividing it out, okay? Because 0.37, I mean, that would equal 37 over 100. So, I mean, it's definitely not going to be exactly equal to that. So I would cross that one off, and I would say it has to be that one. Unless, but the thing is though, yeah, unless they're rounding it. Let me think. Yeah. Because technically this would be bigger. C would be bigger than D. Yeah, okay, that does make sense. Yeah, because this is bigger than 37 over 100. So that makes sense. Because if your denominator increases, the overall value decreases. Okay. And then let's see. number 29, number 30, those are that's just a fancy way of saying change this to a fraction. All right, so I think we're good there. Any questions? Okay. All right, then we will move on to 5.4, which is an introduction to irrational numbers. All right. So the set of irrational numbers is a set of numbers whose decimal representations are neither terminating nor repeating. So in other words, when you write that number as a decimal, it's not terminating, which means it doesn't end, which means it goes on forever. And it's not repeating, so it's just, it's like a kind of seems random, it's not like 3, 4, 3, 4. It's a bunch of random numbers. There's no discernible pattern to it. All right, so the set of irrational numbers contains numbers like pi and the square root of 2.
Miss Bankhead.
In the expression square root of 2, so whenever you see that, you would read that as the square root of 2. Okay.
Miss Bankhead.
Okay, so this is the radical symbol. Okay, that's the radical. The radicand is the number under the radical. So in this example, that radicand would be equal to 2. Okay. All right, and then the whole thing overall is called a radical. All right. The principal square root of a non-negative number n is the positive or 0 square root. Okay. So that means, for example, the square root of 9 is equal to 3. So a perfect square is a number that is the square of a whole number. So for example, perfect squares would be 0, 1, 4. So that's 0 squared, 1 squared, 2 squared, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. So those are examples of numbers that are perfect squares. Okay. All right, there's a product rule for square roots, which is the square root of a times the square root of b is equal to the square root of a times b. And the same thing goes for dividing it. So the square root of a over the square root of b is equal to the square root of a over b. So you can combine them. So you can combine square roots in that way, or you can also separate them in that way if you want. And the number that multiplies a square root is called the square root's coefficient. So for example, if I said 5 square root of 2, in other words, 5 times the square root of 2, then the coefficient is 5 in that example. Just like, variables can have coefficients, like if you had 5x, 5 would be the coefficient. Okay, square roots with the same radicand can be added or subtracted by adding or subtracting their coefficients. So that means something like 5 times the square root of 3 plus 4 times the square root of 3 equals 9 times the square root of 3. So we just added, just like if you said 5x plus 4x equals 9x, it's the same thing. Okay. All right. Some examples. right. So the set of irrational numbers is, okay, so that's just a definition we already talked about. Okay, let's see. The irrational number blank represents the circumference of a circle divided by the diameter of the circle. What do you think the answer to this one is? Here's your choices. Represents the circumference of the circle. Pi. Pi represents the circumference of a circle divided by the diameter of the circle. Let's see. The square root of n represented by blank is the non-negative number that when multiplied by itself gives blank. Okay, so square root of n represented by that is the non-negative number that when multiplied by itself gives what should go in this blank? So the square root of n multiplied by itself equals n. Yeah, so what they're saying is the square root of n times the square root of n equals n. That's what they're saying here. The number that multiplies a square root is called the square root coefficient. We just talked about that. Okay. All right, let's see here. Okay, so here they're trying to illustrate the fact that you can combine like terms basically with square roots. So 44 square root of 13 plus 47 square root of 13. So just add the coefficients. So all they want us to do here is just, I guess, we'd fill in 44 plus 47. And so 44 plus 47 equals 91. So the final answer would be 91 times the square root of 13. All right, and the square root of 49 equals 7, because 7 times 7 is 49. And the square root of 169 equals 13. And the square root of 3 times the square root of 10. So that would be the square root of 3 times 10. So that would equal the square root of 30. And 15 square roots of 13 plus 15 square root of 13 would equal 30 square root of 13, because 15 plus 15 is 30. And the square root of 14 plus the square root of 14. So there's an invisible coefficient of 1 in front of each of those, and 1 plus 1 is 2. So that would be 2 square roots of 14. All right. So that didn't take as long as I thought it would. 'cause that's all I have for you. Has everybody gotten on My Labs Plus now? Well,
I'm having a lot of issue with me. I was trying the day before and yesterday and all of a sudden. What I did is make it easier.
what about you guys on here? Okay. Kathy still having problems? All right. Yeah. If you're good, you're free to go. If you're all good, I'd like to try to figure out what the problem is before you leave. Okay. Well, I mean, you can always click on pay later. Yeah. Let's just do that. Let's try to get it to work. Can we try? You don't have your computer with you, do you? Can we just try it on your phone? See ya. Oops. So why is your name Jackie? Is that what you go by, or is it, or what?
I think it joined through my sister's Zoom on accident.
You what?
I think it joined through my sister's Zoom on accident.
Okay. All right.
But yeah, I'll fix that.
Okay, I was just wondering, like, well, should I be calling you Jackie? I mean, is that
No, I appreciate it though.
okay? All right. Bye.